Okay, so in this set of examples, we have equations that are still linear equations, but they're not written in the form of y equals mx plus b. We're written in a y minus plus bx is equal to c type format. Now, obviously, you can rewrite this into this format, and you may want to do that if you're looking for a y-intercept and trying to do something else with the linear equation. But if all you care about is where the line intersects the x-axis, you can still do it the same way we've been doing it, where we set y equals 0 and then solve for x. So let's take a look at our graph for these three lines. You can rewrite this equation to identify the slope and the y-intercept to verify that these are the correct lines. But let's see if we can match the x-axis intersect point with what the graph shows. So our first equation, 2y minus 6x is equal to negative 6, is this red line here. From the graph, it looks like it's intersecting at x equals 1. So let's see if we can match that. So we set y equals 0, then we get negative 6x is equal to negative 6. So if x is equal to 1, this is true, and so that matches, right? So 3y minus 3x equals 12. That's this blue line right here. From this graph, it looks like it intersects at negative 4, or x equals negative 4. So we plug in y equals 0. We get negative 3x is equal to 12. X is equal to negative 4. So that matches. Finally, we have x plus y is equal to 0. This one should be pretty straightforward. If we wanted to rewrite this in the form of y equals mx plus b, this would just be y equals negative x. This graph right here. So obviously it's going to have x-axis and y-axis intersect point at the origin, or 0, 0. And so if I plug in y equals 0, obviously we see that x equals 0. So real quick, doesn't matter what form this is in, we can solve for the x-axis intersect point by just plugging y equals 0. Obviously, same is true if you want to solve for the y intersect point, you just plug in when x equals 0 and you can solve for what y value is.